This is 765. It says use a half-angle formula to find the exact value of cosecant 17 pi over 12. Where is 17 pi over 12? Well, you'll figure it out. It's in the third quadrant. How do we know it's in the third quadrant? Well, 12 goes into 17 once, and 5/12 is left over, so that's a little bit less than 1.5. Well, here's 3 pi over 2, which is 1.5 pi. That's 1 5/12 times pi, so it's somewhere in the third quadrant. In the third quadrant, cosecant is negative, so we're going to use the negative square root. So when we know what the angle is, when we're given the angle like this, we go by wherever the original angle was. That's what our cosecant is going to be. So negative square root. We'll just do the sine and then we'll flip it. So the sine of theta over 2, oh, what is theta over 2, by the way? So 17 pi over 12 equals theta over 2. So 17 pi over 6 equals theta. So we want 17 pi over 6 over 2. So this is going to be the cosecant. I'll draw this one down here. I'm going to have to get extra space. Cosecant of 17 pi over 6 over 2. And what is 17 pi over 6? Well, 6 times 2 is 12 and 5 left over. So this is 5. It'll be the same as 5 pi over 6 over 2. So we'll do sine of 5 pi over 6 over 2. It has to be negative because the original angle was in the third quadrant. So the unit circle, I believe, gives us 5 pi over 6. Where is the old unit circle? 5 pi over 6. The formula is, for sine, is 1 minus cosine divided by 2. And then we'll flip it. So this is going to be negative square root. Cosine of 5 pi over 6 is negative square root of 3 over 2. So 1 minus negative square root of 3 over 2 divided by 2. And I'm going to need extra room. So remember, for these, when they give you the angle, you go by wherever the quadrant the angle is. That's the sign you're going to assign it. This isn't like when you don't know the angle and you're just doing the sine of theta over 2. This is the cosecant or sine or cosine, whatever, of an actual angle. So you go by whatever the actual angle is, what quadrant it's in. So I have to continue this. I'm negative 1 minus square root of 3 over 2, which is equal to negative square root of 1 plus square root of 3 over 2 equals, well, I can write this as 2 over 2 plus square root of 3 over 1, 2 over 2. So this can be 2 plus square root of 3 over 2 on top, divided by 2 on the bottom, negative square root. So 1 I just rewrote as 2 over 2. And then 2 over 2 plus square root of 3 over 2 is 2 plus square root of 3 over 2. And that becomes negative square root of 2 plus square root of 3 over 4. And now I have to flip it, equals negative square root of 4 over 2 plus square root of 3. And I guess you can write it like that if your computer will take that. If it won't take it, you multiply that by 2 minus square root of 3 over 2 minus square root of 3. You'll still have a square root in the denominator, so who knows, but this will, because this whole thing is a square root. So this is going to be 8 minus 4 square root of 3 divided by 2 times 2 is 4 plus 3 square root of 3 times 2 minus square root of 3 times 2. Those cancel out. Square root of 3 times square root of 3, which is 3. And that whole thing is a negative square root. And that equals negative square root of 8 minus 4 square root of 3 over 1. Oh, look, it got rid of everything in the denominator. So then I can take negative square root. You don't have to do all this, but I'm just doing it. This gives us 4 times 2 minus square root of 3. And the square root of 4 is 2, so negative 2 square root of 2 minus square root of 3. So there's your answer. You can write it whatever way you want. I guess you can put it this way into the computer. You can put it this way into the computer. But remember, the key to this is when they give you the angle, you use whatever quadrant that angle is to determine the ending sign. So in this case, it was the third quadrant. That gave us a negative angle. How do we know it was in the third quadrant? 12 goes into 17 once with 5 left over. So 1 5/12 times pi. Well, this is 1.5 pi. This is 1 and a little bit less than 0.5 pi. So it's in the third quadrant. That's how we figured that one out. So that's that question. And then you can find a decimal value if you want to.